The brilliant Isaac Newton came out with the second Newton's less obvious law for motion. In this case, we will go to the lab. Let's assume we went to the lab. On the table, we already had a cart with a hook on it. We had a pulley over here, and we had 3 weights. Each one of them is 100 kilograms, and you have a string that's going around the pulley. Then you are able, there's a circle here that you can, there's a little hook that you can attach another hook to it, to its edge basically. So you bring the cart, you put 200 grams on it of weight, then you put 100 grams hanging over here. Now there's 100 grams pulling downward, there's 200 grams of weight. Then you have here some kind of recorder that will record, you know, the timing stamps, and it will record the motion and distance. You hang up the 100 grams, then you let the cart roll and you hold the weight before it hit the floor. And you write your observations. You'll record the distance, you'll record the velocity, and you will record the time needed. Then you will do it again. Take this 100 gram and hang it here. So you'll have 200 grams hanging here and 100 grams here. And you create a table for that. Then you calculate the total mass, the distance, the magnitude of acceleration as a result of those variables. How do you find acceleration? Using this equation. You remember this equation of motion, d equals v by delta t plus 1 over 2 by a by delta t squared. A can be represented as equals to 2d over delta t squared. In this case, you start to come up with some relation between stuff. You can realize that there is a relation between the mass of the object and the force being applied on it. So the more mass here, the less mass here, and the more mass here, the more the object will gain acceleration. The less mass here and more mass here, which means more mass of the object, will make the object having less acceleration and less velocity. That means there is a relation between acceleration and mass. Mass goes down, acceleration goes up. As mass goes up, acceleration goes down. That's what Newton was thinking about, and he started from there. To go into a logical progression towards the Newton's second law and how he did come up with it, as we said, he started with the lab and trying to investigate the relation between the mass and the acceleration of the objects. Here we have somebody who's skiing, and you can see a free body diagram for him. There is the air force pushing backward, the friction pushing backward. There's his weight acting as a gravitational force. And let's say his friend pushed him forward with a force called applied force, F-app. Then you have the normal force acting upward. If you do a horizontal forces analysis, you can see there's F-app, and there's F air to the left, F friction to the left, and the F net would be to the right. So the total force will be to the right. The object will move to the right hand side of the picture. In this case, we can see as well there's a relation between the acceleration and the resultant force. So in the first, we realize from the lab that there is a relation between the mass and the acceleration. There's as well relation between acceleration and the force. When somebody pushes you harder, you will accelerate faster. When somebody pushes you slower, you will accelerate less faster. So for the same mass, greater net force will give you greater acceleration. If you push here with a bigger force for this body, while you push here with a smaller force, acceleration for smaller force would be less than acceleration for bigger force, assuming both of their weights or their masses are the same. Now, acceleration and mass relation, we saw that in the lab, but we confirm with our skiing example over here. We have somebody with a mass, you have a certain acceleration. Let's say we are pushing them to the right with the same amount of force. We have somebody who's heavier over here. He have a bigger mass, so when we push him with the same force, he accelerated slower than the guy with a smaller mass. So the relation between acceleration and mass, the more acceleration, the less mass, or the less mass, the more acceleration, the more mass, the less acceleration. Heavier car with the same engine will go slower in acceleration than smaller or lighter car with the same engine and the same acceleration and the same power. The mass inertia in Newton's second law. We mentioned inertia in the first Newton's law of motion, that there is a relation between the mass and inertia, and here we are defining the mass inertia that is playing a big role in Newton's second law. The proportionality between the acceleration and the net force and the acceleration and the mass can be combined into one statement. So the acceleration is, as acceleration goes up, the net force goes up, or vice versa. And as the mass goes down, acceleration goes up. As the mass goes up, acceleration goes down. In this case, we can say acceleration equals a constant k that we don't know, multiplied by the resultant force over the mass. So the k here is the proportionality constant. In math, to change the proportion relation into an equation, you need to have a proportionality constant, which is k. But we know that 1 Newton is defined as the net force required to accelerate 1 kilogram object at 1 miles per second squared. Then in this case, k is equal to 1. So the equation can be written as acceleration equals the F net over the mass. Acceleration is in a negative relation with mass. As mass goes up, acceleration goes down. As mass goes down, acceleration goes up. So now we can summarize the Newton's second law of motion the way Isaac Newton described it. When there is an external force acting on an object, the object accelerates in the direction of the resultant or the net force. The magnitude of acceleration is directly proportional to the magnitude of the net force and inversely proportional to the value of the mass of that object. So the whole geniusness here, going to the lab and finding the proportion between the acceleration and the force, that's one big thing. It was hard back then to imagine there's a relation between acceleration and force, and the acceleration and the mass. It is proportional relation between acceleration and force. Force up, acceleration up. Force down, acceleration down. I mean in value. And the mass, the higher the mass, the less the acceleration. The lower the mass, the bigger the acceleration. And you can describe the force in this case as equal to mass by acceleration. So the force, in short story, with the help of mass can generate acceleration. That was the geniusness of Newton in that time of describing the relation between the force, mass, and acceleration.